Welcome to this tutorial where I'm going to show you how to calculate the t-value of a paired samples t-test, also known as a dependent samples t-test. First, for the data setup. We have 25 cases here, 25 respondents. Those are our business partners. And we wanted to know how they perceived our company. So we asked them about our company image after 3 months and after 12 months. The higher the score, the better the company image. Each case was measured twice. The only difference being when we asked them about our company image. These two measurements differ only in the point in time, but it's the same case. So 2 measurements for each case. That is why the test is called dependent samples t-test or paired samples t-test, because of these paired measurements. Now, the reason for this could be that we have launched a communication campaign or whatsoever. So we might have some reason to believe that the image changed, or we just want to make sure how we are doing. Let's have a look at the formula. What does this say? Well, to calculate the t-value, you have to calculate the mean of the differences first. And then you divide this by the standard error of the mean of the differences. This basically says that the difference you're picking up here between the measurements has to be standardized in some way, because this fluctuation, this difference, might be due to chance. You're just looking at the sample, but you want to make an inference about the population. So you take the standard error so that you standardize this difference and can be sure that what you're picking up is not just due to chance, but is a real difference. So this standard error of the mean of the difference is like any standard error, just the standard deviation divided by the square root of the sample size. So in the denominator, you have just summed this up. The standard deviation divided by the square root of the sample size. Just put together. So that's how you calculate the t-value. Now let's look a little bit more in detail how you do this. So first, the mean of the differences. So what you will do first is you have to calculate each difference. So you go through each row and calculate the difference. Then you take the mean, the arithmetic mean of those differences. I will not go into actually calculating the mean. I just use the Excel formulas, as you can see here. And of course, you know the sample size, n, which is here 25 cases. So what's the standard error? The formula is not so complicated here. I use the Excel functions. So you take the standard deviation of those differences and divide it by the square root of the sample size. And then you plug this into the formula. So this is our t-value, and the according degrees of freedom is just your sample size minus 1, because you're estimating one mean. Now, usually what you could do now is you look at a critical t-value table and see if your calculated t-value here exceeds the critical t-value in the table. In the table, you will have the degrees of freedom. You calculated those, and you will have set an alpha level before doing the test. Usually this is 0.05, and there you will find a critical t-value. So if it exceeds that, if this value exceeds this critical value, it is significant. Well, the t-value for this, the critical t-value for this is about 2. So this is clearly highly significant. It's for sure exceeding the critical t-value at 0.05 as alpha level. So there is a difference in the company image. But what you could also do, and statistic software packages do this automatically, they will calculate the exact p-value for you. So you can see that this is highly significant. This is how you calculate the t-value, and you can make an inference about the population. So we can say that we have a shift in the company image here. So as we deducted here the first minus the second, and the t-value is negative, so our company image has improved significantly.